Imagine like a universe, okay, where energy could just like appear out of nowhere, poof,
Right.
or like disappear, completely gone.
Yeah.
It'd be chaos.
Total chaos.
Luckily, our universe plays by the rules.
Mm-hmm.
You know, energy can't be created or destroyed.
Right.
Only transformed.
Mm-hmm.
But why, though?
Yeah, that's the big question.
Why? Enter Emmy Noether,
Ah, yes, Emmy Noether.
a mathematical genius who, like, revealed one of the universe's best-kept secrets.
Secrets. Yeah.
Symmetry.
Mm.
Today's deep dive is all about Noether, her groundbreaking theorem.
A theorem, yes.
And how it shapes our understanding of everything.
Everything.
From tiny particles
Or like the really, really tiny stuff.
to massive black holes.
The giants of the cosmos.
Buckle up, because things are about to get mind-bendingly awesome.
Hooray.
You can say that again. So Noether's story starts in 1882,
Okay, 1882.
a time when women were practically excluded from academia.
Really?
Oh, yeah. Imagine being told your brain isn't meant for science just because of your gender.
Wow, it was a different time. Yet
Yeah.
Noether defied expectations.
She did.
She earned a PhD in mathematics?
A PhD in mathematics.
Can you imagine?
Wow.
Even then, she couldn't get a paid teaching position.
Seriously.
So she worked for free, contributing to her father's lectures.
That's dedication.
Oh, absolutely.
It's almost unbelievable. Here's this brilliant mind fighting tooth and nail to do what she loves.
Yeah.
It makes her achievements even more incredible.
Absolutely. And her biggest achievement,
Yeah.
Noether's theorem.
Okay, Noether's theorem.
It's a bit like a universal cheat code,
Cheat code.
connecting the concept of symmetry to the laws of physics.
Okay.
Symmetry, you ask.
Symmetry.
Think of a snowflake.
Okay.
It's symmetrical, meaning it looks the same from different angles.
Right.
Noether showed that these kinds of symmetries in nature
Okay.
are directly linked to fundamental conservation laws.
Oh, okay. That sounds pretty abstract.
It is a bit abstract.
Can you give me a real-world example?
Sure. Imagine a spinning basketball.
Okay, got it.
It looks the same no matter how you spin it right. That's rotational symmetry.
Okay, rotational symmetry.
Noether proved that this symmetry is the reason why angular momentum,
Angular momentum.
a measure of how things rotate, is always conserved.
Whoa, so the shape of something is tied to a fundamental law of physics.
It is. That's crazy.
It is, and it gets even wilder. Think about energy.
Okay, energy.
One of the fundamental laws of physics is that energy can't be created or destroyed.
Right, one of the very basics.
Noether's theorem shows us that this law is a direct result of another type of symmetry.
Another one.
The fact that the laws of physics are the same everywhere and at all times.
Everywhere and at all times.
That consistency, that sameness is a form of symmetry too, and it's directly connected to why energy is always conserved.
So this symmetry rulebook governs the entire universe. It's like a hidden code behind reality. Noether's basically cracked the code, and that's why her work is so revolutionary. Exactly, and that's just scratching the surface. Noether's theorem isn't just some abstract idea. It underpins pretty much all of modern physics.
All of modern physics.
Pretty much.
Wow, okay, my brain is officially doing backflips.
Yeah.
We've got spinning basketballs, energy conservation, and a symmetry rule book governing the universe. Where do we even go from here?
Well, let's talk about one of the most mind-boggling concepts in physics, black holes. Those cosmic monsters that warp space and time. You know, the things that even light can't escape.
Yeah, black holes.
Yeah.
They're like the ultimate cosmic mystery. What do they have to do with Noether's theorem?
Everything. You see, our understanding of black holes comes from Einstein's theory of general relativity. It's this incredible theory that describes how gravity works not as a force, but as a curvature in space and time.
Wait, so gravity isn't a force. It's a curvature. My mind is melting.
It's a mind-blowing concept, isn't it? But here's the key. Einstein needed a way to describe how energy and momentum are conserved within this warped space-time. And guess what provided the mathematical framework for that?
Noether's theorem.
You got it. It was a crucial piece of the puzzle that allowed Einstein to develop his theory of general relativity. Without Noether's insights, our understanding of black holes' gravity and the very fabric of the universe would be completely different.
Wow. It's like Noether provided the scaffolding for one of the most important theories in physics. But it doesn't stop there, right? The article also mentioned quantum mechanics, which is a whole other level of weirdness.
Quantum mechanics is the study of the very, very small, the world of atoms and subatomic particles. It's a realm where things can be in multiple places at once, where particles behave like waves, and where the very act of observing something can change its state.
It's like the universe is playing a cosmic game of hide and seek down there.
You could say that. But even in this bizarre world of quantum mechanics, Noether's theorem reigns supreme. Take something called quantum spin, for example.
Quantum spin. Is that like a tiny little particle spinning around?
It's kind of like that, but not quite. Quantum spin is a fundamental property of particles, like their electric charge or mass. But here's the crazy part. The conservation of this quantum spin, this intrinsic angular momentum of particles, is also linked to rotational symmetry, thanks to Noether's theorem.
So even at the smallest scales, this idea of symmetry has these deep connections to physics. It's like Noether gave us a universal key to unlock the secrets of the universe.
And the story doesn't end there. There's another big player in the world of physics where Noether's theorem has a starring role, the standard model of particle physics.
The standard model. Isn't that the model that explains all the fundamental particles and forces in the universe? The one with quarks, leptons, and bosons?
The very same. It's like the periodic table, but for the building blocks of the universe.
Yeah.
And Noether's work is woven into the very fabric of this model.
How so?
Well, the standard model relied heavily on the concept of symmetry. In fact, many of the particles predicted by the model were discovered based on symmetry arguments. And these symmetry arguments stem directly from Noether's theorem. It's like she provided the blueprint for understanding how these fundamental particles and forces interact.
So her work isn't just about explaining what we already know. It's also helping us predict and discover new things about the universe. That's incredible.
Exactly. And it highlights another fascinating aspect of Noether's legacy. Her work is still relevant today, shaping cutting-edge research in areas like dark matter and dark energy.
Dark matter and dark energy. Those are like the biggest mysteries in cosmology right now. What does Noether have to do with them?
Well, scientists are still trying to figure out what exactly dark matter and dark energy are, but many theories that attempt to explain these phenomena rely on new symmetries and conservation laws. And you can bet that Noether's theorem is playing a key role in those theories.
This is seriously blowing my mind. It's like Noether's work is this endless well of insight. Every time we think we've reached the bottom, we discover something new.
It's a testament to the enduring power of her ideas. They've become so fundamental to our understanding of the universe that it's hard to imagine modern physics without them.
Okay, so we've gone from spinning basketballs to black holes, from quantum spin to the mysteries of dark matter. I think my brain needs a moment to catch up.
It's a lot to take in, that's for sure, but it's also incredibly exciting. Noether's story shows us that even the most abstract mathematical concepts can have profound implications for our understanding of the universe.
It makes you wonder what other secrets the universe is hiding and what other brilliant minds like Noether's are out there waiting to unlock them.
And that's the beauty of science, isn't it? It's a never-ending journey of discovery. And Emmy Noether's legacy continues to inspire us to explore the unknown with curiosity, courage, and a deep appreciation for the elegance and power of the universe's underlying symmetries.
So we've like journeyed from the everyday symmetry of a spinning basketball to the mind-boggling depths of black holes and the subatomic realm of quantum spin. It's amazing to think that one woman's insights could have such a profound impact on our understanding of the universe.
It really speaks to the power of a single idea, doesn't it? Noether's work wasn't just about equations. It was about revealing a hidden connection, a beautiful symmetry that underpins the very laws of nature.
It makes you wonder if there are other such elegant connections waiting to be discovered. What other mysteries might be unlocked if we just learn to see the world through the lens of symmetry?
That's a question worth pondering. Noether's legacy is a reminder that the universe is full of surprises, and that even the most fundamental laws of physics can be understood in new and deeper ways.
It also makes me think about the human side of this story. Here's this brilliant woman who faced incredible obstacles just to pursue her passion. Imagine the world we live in if we could unleash the full potential of everyone, regardless of their gender background or the challenges they face.
It's a powerful thought. Noether's story is an inspiration to anyone who's ever felt like an outsider, anyone who's been told they can't achieve their dreams. It's a reminder that brilliance can come from anywhere, and that we should never underestimate the power of a single determined mind.
Well said. So to wrap things up, what's the one takeaway you hope our listeners will carry with them from this deep dive into Emmy Noether's life and work?
I think the most important lesson is to embrace curiosity. Never stop asking questions. Never stop exploring the world around you with a sense of wonder. You never know what amazing discoveries you might make, what hidden connections you might uncover.
And never give up on your passions, no matter what obstacles you face. Who knows, maybe you'll be the next Emmy, revolutionizing our understanding of the universe with a single brilliant idea.
And if you ever find yourself marveling at the beauty and complexity of the universe, remember the name Emmy. Noether, her work helped us unlock some of the deepest secrets of the cosmos, and her legacy continues to inspire generations of scientists and dreamers. Thanks for joining us on this incredible journey. Until next time, keep exploring.